So yesterday we talked about Pythagorean theorem, and that we, in order to solve and find our answer, we had to take the square root, right? And that's what this chapter is all about, is square roots. In lesson 10.2, we get to start looking at simplifying radicals. Okay, so being able to simplify a radical. Now, while I was getting stuff done, this is why I asked you guys to fill out perfect squares. This chart right here is going to be a chart you're going to want to refer to a lot, because these are our perfect squares. When I talk about perfect squares, for instance, I'm saying, okay, 25 is a perfect square. Why is 25 a perfect square? What do I mean by that?
Like 5 can go perfectly.
Yeah, because it's 5 times itself, right? It's a number times itself gives me 25. So those are perfect squares. If you happen to go across, which I know we all tend to go down, you would notice that they went in order, right? So what I did is I gave you all the perfect squares up to 144, which is 1 through 12. Okay? So we're going to be using these to try and simplify radical expressions. So, when we get down to, say, square root of 72 down there, we can take the square root of 72, short of using our calculator, which gives us a decimal. So we're going to practice simplifying. So, a little bit of vocabulary. A radical expression is an expression that contains a radical. Do you guys know what I mean when I say radical? Radical being a square root sign. Okay, now I think the Algebra 2 books sticks pretty much with square roots. When we get into the Algebra 2 book, they do more cube roots and more like that. But when we're talking about radicals, I'm talking about a square root sign. Sorry, I use that word and I forget that not everyone is familiar with that word. So when I say radical, I'm talking about a square root sign. Now, a radical expression, so like a square root expression, is simplified if the radicand, so that's the number underneath it, has no perfect square factors other than 1. It contains no fractions, and there's no radicals in the denominator. So to help explain that, here are some examples. Okay, so simplify. 3 square root of 5 is simplified because there's no perfect squares in 5. There's no factors I can pull out that are perfect squares. 9 square root of x is simplified. Same thing. Okay. Is your phone in here?
No, I left it in the office. I forgot I had that.
Does it still connect this far away?
No, I doubt it.
Okay. I would say it probably doesn't connect, at least not a whole lot, but. Okay. And then square root of 2 over 4, this is simplified because there's no square roots in the bottom. Okay. These are examples of not simplifieds. 3 square root of 12. Square root of 12 is not simplified because 12 has a factor of 4. And 4 is a perfect square. Okay? Square root of x over 2 is not simplified because you can't leave a fraction under a radical. And I think I'll probably hold off and we'll talk fractions tomorrow. I think that would be too much today. So that's in part 2, and I don't think I'll plan to do part 2. I'll just look at part 1. 5 over square root of 7, not simplified because there's a square root in the bottom. Okay? So those are some examples. And so our goal is to get things simplified. Okay. So, square root of 72. One thing I would always check, is 72 a perfect square? And it's not, because first of all, it's in between 64 and 81. And 64 is a perfect square, 81 is a perfect square, but that's 8 and 9, so there's no perfect squares in between those. But what we need to figure out, are there any perfect squares in 72? This is where you want to have a calculator by your side, and you want to have this list of numbers by your side. So does 72 divide by any of the numbers up here that are in square roots? And you always want to go for the biggest possible. But we can make it work if we find a smaller one as well. Okay. But 12 is not one of my numbers under a radical. Okay, so we want to look at numbers under the radical. And I use these in my Algebra 2 class, and I thought you guys would appreciate these too. Now, I would just, study the first two columns. Don't look at cube roots, fourth roots, fifth roots. That's something we talked about in Algebra 2. But we just focus on these. Or really even that first column has what you need, right? Are there any of those numbers that 72 divides by?
36.
Okay. Mikhaili found 36. So if I take my calculator, 72 divided by 36, that gives me a nice neat whole number 2, right? So, one option here, I'm going to rewrite this. 72, still under the radical. Is that a true statement? Square root of 72 is the same as square root of 36 times 2?
Yes.
Because 36 times 2 is 72, right? I haven't changed anything. So what we're looking at, and maybe I should have gone ahead and written it, we can break this into two separate square roots. If I break this up into two separate square roots, this is the square root of 36 times the square root of 2. What do you know about the square root of 36?
6.
It's 6. What about the square root of 2? Is it on my list? No. If I do square root of 2 on my calculator, I'm going to get a decimal. So we leave square root of 2, right? We don't want decimals today. So the square root of 36 is 6. Square root of 2 stays square root of 2. So the simplified version of this radical is 6 square root of 2. Now, hesitate. Do I want to ask? I probably should. So Mikhaili, you said it divides by 36. Had you found anything it divided by, Jacob?
My calculator would work
It also has phone number.
Okay, and that was my question is, okay, could we have taken a different route here?
Oh.
Yeah.
And we could have. You just have to know that you can't stop too soon. Okay? My recommendation is go for the biggest number you can. Okay, don't just stop, oh, hey, it divides by, did you say 4, Mikhaili?
Yeah.
Yeah. So here's just an alternate option, and it would have worked if we had done 4. This would have been 4 times what is 72? Take your calculator and do 72 divided by 4?
18. Yeah.
18. Here's the question, okay? 4 is good. We know we can take the square root of 4. Does 18 have any other perfect squares in it? So does 18 divide by any of these numbers here? Does 18, well, 1 doesn't really matter, right? Does 18 divide by 4? No. Does 18 divide by 9?
Oh, yes.
Yeah, it does, doesn't it? So what you're going to end up realizing, so here, so square root of 4 was what? 2. But here's the deal. You can't stop at 2 square root of 18 because 18 can divide by 9. So if we go another step here, 18 is 9 times what?
2.
Times 2. So it's the square root of 18, which means I can say square root of 9 times square root of 2. Well, what do we know about the square root of 9?
It's 3.
It's 3. So we already have this 2 out front, this 3 out front, and then the square root of 2 still. 2 times 3 out front is 6 square root of 2. Same answer, right?
Just longer.
Longer process if you ask me. So that's my encouragement. Always go for the bigger number. Get that? Thank you, sir. to be graded pile keeps growing. So yeah, my point is you can do the longer process.
Does it take long?
Yeah. So this is why I'm always going to encourage you to look for the biggest number possible. Okay, you ready to try the middle one? I'm realizing I have these kind of small as I walked back there. I was walking forward. Sorry. Okay, square root of 125. So you're grabbing your calculator, you're grabbing your blue paper, and you're taking 125 and trying to see, okay, what does it divide by? Okay, and
We get 5.
okay, and to get there, you know, I might check first, okay, does it divide by 100? Does it divide by 81? Does it divide by 64, 49, 36? And as I check each of those, I know it doesn't divide them because I get decimals, right?
Yeah.
It's like 125 divided by 36, I get a decimal. So that doesn't work. But it divides by, what'd you say, 25?
Yeah.
So that means I rewrite this as
25.
25 times 5. Both numbers are under the square roots, right?
Yeah.
So I just rewrote 125 as 25 times 5. What do you know about the square root of 25?
It's
Is it times 5?
That's 5, right?
Yeah.
Square root of 25 is 5. What about the square root of 5? That's a decimal, so we leave it as square root of 5. You're done unless,
Unless you do the harder process.
well, and in this case there isn't really a longer process. Because does 5 have any perfect squares left in it?
No, it's just.
No, it's just 5 times 1, and so you're done right there. Okay. Now, I don't know if you guys caught on. I handed out the blue paper. I forgot to. You guys realize what order these are in? The square root of 4 is
2,
2. The square root of 9 is
3,
3.
4, 5. Yeah.
They go in order? Okay, so I don't write on there what they equal, but if you want to, you could. That's your choice, okay? Okay, let's try one more with just numbers here. Square root of 98. Well, first of all, is 98 a perfect square?
No.
No, the square root of 98 is 9.8994949. Yeah, okay, no. So what am I doing?
Finding the.
Take your calculator.
It's 49.
Does 98 divide by, say, 81?
No.
No, I get a decimal. 98 divided by 64? No, I get a decimal. 98 divided by 49?
Yeah.
Oh, hey. I got not a decimal, right? Are you doing okay with that process, Jacob?
Yeah.
Okay. Because I'm just taking my calculator and I'm just dividing. So I can write 98. What do we say 98 became?
49.
49 times 2,
Oh, yeah, 2. Jeez. I don't know why I put that.
right? Because when I do 98 divided by 49 on my calculator, I get 2.
Square root of 49.
Yeah, I say, you were mixing your numbers up. Okay, what do we know here?
Square root of 49 plus 7.
Square root of 49 is 7.
Square root of 2 is.
Square root of 2 is a decimal. 1 times 1 is 1. Don't fall for that trick. Square root of 2 is a decimal, so we're going to leave it as
2.
the square root of 2.
I might read it wrong in my head.
So 7 square root of 2. Okay. We getting the hang of that a little bit? Okay, let's go to the next part then. Which I think I do have it up here on the next page. Square root of 16 m to the 5th.
Okay.
Okay. So we have to think about numbers. We have to think about variables. So we have to think about the letters. So let's look at 16. What do you know about 16?
It's a perfect square root.
It's a perfect square, isn't it? It's on my paper. If I put it in my calculator, I'm going to get an answer. So square root of 16, I'm going to leave as square root of 16. Because then later on down the next step, square root of 16 is going to become 4. If we needed to break it up, like the others we just broke up, we would. Now, m to the 5th. So, can we take the square root of m to the 5th?
No. Maybe.
Okay. You're not sure, right? And here's the deal.
Yeah, essentially what those root was.
Well, no, I mean, I was just curious with what you guys say. I'm going to say m to the 5th is odd.
Yeah.
So I know that I can't take the square root of it. When we talk exponents, and this is where you have to be careful because we're talking exponents, can we do m to some power times itself and get m to the 5th? And we can't. Okay? What you need to think about when we're doing square roots, you divide a power in half. So, I'm trying to think the best way to explain this. What is the closest power below 5 that's even? 4, right? So what I'm going to do is I'm going to break this up. Instead of having m to the 5th, I'm going to break it into m to the 4th times m to the 1st. I know what I should have started off with. How much am I going to mess you guys up if I side note for a moment? I'm probably going.
No clue. So
Okay. I'm going to use this little piece of this box, if you have a piece of your box. I'm realizing, as I get into this one, I should have started with a better example. I'm going to start with this more basic problem, and we'll go back to that one. Square root of x to the 6th. And if you don't have room right there, maybe you have room over to the right of the other problem. So when we talk about the square root of x to the 6th, what you're asking yourself is x to what power times x to what power equals x to the 6th. Now, what do? We multiply with like bases. What do we do with the exponents?
you just add like 3. That's what equals 6.
You add, right? So when we're multiplying with like bases, we're adding the exponents.
That's 3.
What number plus itself equals 6?
3.
And that is 3. So x to the 3rd times x to the 3rd equals x to the 6th. So with that in mind, what's the square root of x to the 6th? X to the 3rd. Now, the shortcut there, notice, how do you get from 6 to 3?
You broke it down.
Divide by 2 is what I would say, right?
Yeah.
Because it's a number plus itself that equals 6. So, in order to take a square root, the easiest thing to do is say, okay, I'm going to do 6 divided by 2 gives me 3. So if it divides by 2, we can take the square root. If it doesn't divide by 2, we can't take the square root. Okay, so can we go back to this problem now?
Yeah.
We had m to the 5th to start off with. 5 does not divide by 2. We get a decimal, right? We don't want decimals. So that's when I said, okay, what's the closest number below 5 that does divide by 2? And you said 4. So that's why I broke it up into 4 and 1.
No, 4 plus 1 equals 5.
Right? And 4 plus 1 is 5, which is why I did that, right? So now, the square root of 16 here. Sorry, Emily, I saw your face and it just...
I was trying to remember the last one. Got it.
Ah, now I know what you're doing.
Yeah.
I thought maybe since we just said 4 plus 1 is 5, we struck something for you, but it came to you. Good. You got all 12 then?
Yeah.
Good. You're happy then. Okay. Square root of 16 is 4. What's the square root of m to the 4th? M to the 2nd. Because 4 divided by 2 is 2. What's the square root of m to the 1st?
One.
Can 1 divide by 2?
No.
Not nicely, right? So what do we do with the square root of m to the 1st? You leave it under the square root. So my final answer, when I put this all together, the 4 m squared times the square root of m. Okay? So kind of like up above, I was breaking the numbers down. Now we have to break variables down too. Okay. Ready to try the next one? Yes, I have up there lesson 10.2 in Math Excel. You're not going to be able, I'm not going to teach all of it today, so you're not going to be able to do all of it today. You can start it. I forgot to write the word begin. You can start 10.2, and what I'm going to tell you to do is to attempt the ones that aren't fractions. Okay? Had I thought about this better, I might have done 2 separate assignments, but it's all right. So I'm going to tell you to attempt the ones that aren't fractions tonight. So the ones that are similar to what we're doing right now in class. Okay? Okay. Negative m square root of 80 m to the 9th. So, break it into pieces here. First of all, that negative m out front. What do you think I get to do with it?
Break it down.
Well, it's already outside of a square root, though. So that negative m out front,
Yeah.
we just carry it down. It's already outside of the radical. You carry it down. It's part of your final answer eventually. Okay? Let's look at 80. You grab the calculator, right?
Yeah.
You're using that first column on the blue paper. What is the biggest number that 80 divides by?
8. Okay. 8. But I probably won't.
Well, 8's not on this blue paper, though, in the first column.
Yeah, I realize that, brother.
So, like, I would start, does 80 divide by, say, 64? I always start big.
16.
80 does not divide by 64. I get a decimal. Does 80 divide by 49?
No.
Nope, I get a decimal. Does 80 divide by 36?
No.
Nope, I get a decimal. Does 80 divide by 25?
No.
Nope, I get a decimal. But you see what I'm doing, right?
Yeah.
That's 6.
Does 80 divide by 16?
Yeah.
5.
Okay, so I'm going to rewrite the square root of 80 as the square root of 16 times the square root of what? 5. Because when we on our calculator we did 80 divided by 16, we got 5. So 16 and 5. Now, m to the 9th. Don't get tricked here. Can I take the square root of m to the 9th? And remember, in order to take the square root of an exponent, it has to be able to...
Yeah, subtract 1, so to the 8.
Yeah.
And into the first.
Yeah. So m to the 9th as is does not, right? Because m to, just like m to the 5th, it's odd. I can't take 9 and divide it by 2. So we're going to make this, what is the closest number below 9? We're going to say m to the 8th. So I've got square root of m to the 8th, square root of m to the 1st. Okay. Now it's just the final cleanup step here. Negative m is still going to carry down. What is the square root of 16?
No, sorry, my brain's not working today. It's 4.
4.
I don't remember it.
Okay. What is the square root of 5? A decimal. So that means I'm going to leave this as square root of 5. And I'm going to kind of scoot it over to the right for a moment. What is the square root of m to the 8th? What do we do with exponents? Over here.
4. Yeah.
Yeah. In order to get the square root of x is 6, we had to take 6 and divide it by 2, right? So what are we doing with 8? Divided by 2, it's going to become m to the 4th. What about the square root of m to the 1st?
Oh, that stays.
Yeah, 1 does not divide by 2. So I'm going to say square root of m. Now, we're going to put it in a nicer form of an answer. Square root of 5 times square root of m is going to be square root of 5 times m is 5m. Over here, with our pieces that are outside, we have a negative and we have a 4. Yes? If you think of this, if you want, you could think of this as a negative 1. What's negative 1 times 4?
Negative 4.
Negative 4. And then we have m times m to the 4th, which is going to be m to what power?
The first.
What?
The first.
No. If it's m times m to the 4th.
Oh, to the 5th.
When the bases are the same, we keep the base of m and we add the exponents. 1 plus 4 is 5. So final answer there of negative 4 m to the 5th square root of 5m. Wow, time has gotten away from us today. Okay,
Oh my gosh.
one more. And then we'll quit today. We'll just call that a good stopping point. Okay, 3 square root of 6 times square root of 18. We haven't had any where we have to multiply radicals, have we? So in order to multiply these radicals together, good news is, as long as it's a square root, you can multiply a square root times a square root. So I would encourage you to multiply them together first before we try and do our square roots. Now, the 3 is outside, so the 3 is going to drop down out front. Good. Stay outside. What is the square root of 6 times the square root of 18? Square root of 108? Because the calculator tells me that 6 times 18 is 108. Okay. Do I get to stop here? No. What do we do? We're going to take our calculator, and we're going to take 108, and we're going to take the list of numbers on our blue paper, and we're going to see what happens here. So, what does 108 divide by? Does 108 divide by, you can start as big as 100, can't you?
Yeah.
Does 108 divide by 100? No, we get a decimal. Does 108 divide by 81? Nope. Does it divide by 64?
Mm-hmm. It's
108 divide by 49?
No.
Does 108 divide by 36? What?
Oh, did I skip that one?
I don't know, did you?
3.
No, yeah, I must have skipped that one.
Man, you said you had it. I thought you had
I
it. What'd you
thought
have?
I did 9, so I must have skipped past it.
And 9 does work,
Yeah.
but like earlier, we'd have more steps. So, not going to say it doesn't work. It would. Okay, the 3 I'm going to keep out front. What did we say 108 was?
36.
36 times 3.
I didn't even realize I skipped over it. I was just.
You said you had it. I was like, good. And then you said no to 36. I was like, dang it. Okay, so what happens here? This 3,
We dropped down a bit.
okay? Square root of 36?
6.
6. Square root of 3? Drop down essentially, right?
Yeah.
What can I put together to finish this problem up?
3.
6 and 3.
3 times 6 is 18. Square root of 3. Okay. That is probably a good place to stop, unless you guys want to do one more with a variable. But
Doesn't matter.
it's actually not too bad of one, really. Well, I don't know which way I want to teach it, though. Okay, well, I'm going to go with my general rule of thumb. When you have two radicals, what did I have you do here?
Multiply the.
Multiply them together, yes?
Yeah.
So that's what I normally say. So if we multiply these together, thank you, 18, square root of 18a to the 4th, because
Doesn't matter.
there's an imaginary 1. Good. Now, we put them all together, but now we have to break it into pieces. Can I take the square root of 18? That's one thing I always check first.
No.
No.
Nope, it's not on my perfect square list. It's a decimal. But what does 18 divide by? Divides by 9.
There's the one record.
Which, so it's going to be 9 times what? 2. Which I know, ironically, that's what it was to begin with. But if I try and teach you the same process, multiply and then separate. What about a to the 4th? Can I take the square root of a to the 4th?
Yeah, it's 2.
Yes, because I can divide by 2. So we're just going to leave this as square root of a to the 4th. Square root of 9 is 3. Square root of 2 is a decimal, so we're going to leave it as
2.
square root of 2. Square root of a to the 4th.
A to the 2nd.
Divide by 2, and it's a to the 2nd, which means it's no longer under the radical, under a square root. Put this in final answer form, which means we want these pieces in front of the radical. So I'm going to write this as 3a squared.
Thursday will be TC Against Drugs. Wear your TC spirit wear. This is for Red Ribbon Week.
TC against drugs.
Picture retakes are November 16th. If you need a retake or you have not had a photo taken, Mr. Summers will be here on the 16th. 6th grade boys basketball. Your practice will start tonight at 6 in the high school gym. Team Black, don't forget they have a Halloween party tonight for grades 6 through 12. Food and fun. Costume contest with prizes. This is from 6:30 to 8:30. Varsity football, don't forget your cleanup and turn in has been moved till tomorrow after school. Seniors, make sure you're checking your emails regarding scholarship information and college visits. There's several on there. Please see the College Stinson High School office. Jacob Shively, Levi Monroe, Jason Courtney, James Kendall, Owen Witt, Brian Van Diemeter, Catherine East, and Spencer Stevens. Thank you. Have a great evening.
Spencer Steven.
Okay, guys. He's an 8th grader, and he's in Alaska right now, so.
Whoa.
It's like Alexander Kevin. 2 first names.
It's Stevens, actually, though.
Stevens?
Yeah,
Why
with
the
an S
same?
on the back.
That's for the S though.
But he meant like Kevin.
No, Spencer Stevens. No,
He
sorry.
was just lying.
Okay. Anyways, begin lesson 10.2. Okay? So if you see a fraction in it,